channel Knowledge of Film. Subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class. This is being your class 10th here, as you can see. And in the last 9 classes, we had started with Unit 1, which has been the computer arithmetic errors and rules of equation. Where in the last classes we had even though done here itself, that is being of course related towards that is about we had done your unit 1 and with respect towards unit 2 as well. And we had started with, and here in the we had done your bisection method, and even though we had started with your unit second which we have here, and that has been of course in the same cases we had done even though here we had started with second method here, and that what even we have to discuss here as well. So here for this we'll start discussing about the iteration number 3. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well as I'm going ahead. Yes, in the last classes we had done this, and if you had not visited that, you can go ahead, you will find it out, then only you are able to find it out this as well. Okay, so here we go ahead for iteration 3. That is now the new interval is a equals to 0.5, b equals to 0.55 here. Okay, so with the same cases we go ahead, and that even though we have to talk about it, we'll put the value here, which is mean the c equals to a plus b by 2. Yeah, and then after that we talk about it. So yes, we'll go ahead for the same 0.5 plus 0.55. Okay, so 0.55 upon 2, so where that is being equals to 0.525. So here for the same we go ahead here, we'll solve it out, then we'll get it. So we'll go ahead for the f of c and for f of a, and of course f of a and f of b as well. That is being important one, and that one even though we have to discuss there as well as in the detail about it. So f of c equals to f 0.525 equals to minus 0.022167. F of a is equals to 0.5, which is equals to 0.0532219. F of b equals to f 0.55 equals to minus 0.100765. So since 0.5 and f 0.525 less than 0, so root lies 0.5 and 0.525. Now for iteration 4 we go ahead here, that even though we have to talk about it, which has been of course important one as well, we'll go ahead for the same iteration 4. So new interval is here, that has been a equals to 0.5, b equals to 0.525. So hence c equals to a plus b by 2, which is equals to 0.5 plus 0.525.2 equals to 0.5125. So f of c equals to f 0.5125 equals to 0.015923. F of a equals to f of 0.5 0.05322219, 0.525 minus 0.022167 here, since 5125. So root lies in 0.5125 and 0.525. Similarly, remaining iteration that can be performed following table list, that the calculation of these iterations we have. We made a table here, and that is we have to made it up first, and we go ahead for the same. So here we that is being important for you. So we have a table here which is with iteration number, new interval, a comma b, a f of a, f of b, and f of c. For this we have here that what we have to talk about it, that what we have to discuss here. Five, 6, 7, 8. So for the same, 0.5125 and b equals to 0.525. This is you have here for the same for 6 iteration. That we have your values 0.517188, 0.001733, b equals to 0.518750, 0.517969. So that we have here, this is a solution using a bisection method. So as you can see from the above table, that you have to note that the 7th iteration root is that what we'll get here is 0.517188, and for the next we have for the 8th iteration root, which is 0.51737969 as well. So on the same phase, the root repeats up to 3 significant digits and after decimal point. So hence root 0.517969 is correct up to 3 decimal places. Now we'll have to find out for to obtain root using a false position method as well. So we go ahead for the same, and that what we have as follows as well. So we talk about the third one, which we have to go ahead, that is to obtain a root using false position method. Okay, so in the same case we find it out here, that is very important of course for the iterations as well, that what we have to discuss here, and which is being important too. So on the same behalf of it, that we know that the root that is like 0.5 and 0.6, hence let us take x0 is equals to 0.5 and x1 is equals to 0.7. x0 is equals to 0.5, x1 is equals to 0.7 as an initial approximation. So fx0 is equals to f0.5 equals to 0.5322, and fx1 is equals to f0.7, which is equals to minus 0.644785. So we'll go ahead for iteration 1. For iteration 1 we talk about it. So for the same we have next root in regular Farsi method that is to be given here, which we have to talk about it. So it will be x2 equals to x1 minus x0 upon fx1 minus fx0, fx1 here 0.7 minus 0.5 upon minus 0.644785 minus 0.053222 upon minus 0.644785 equals to 0.515250. fx2 is equals to f of 0.515250. Now for fx1, f0.7, which is minus 0.644785. We have fx0 is equals to f0.5, 0.053222 here, that we have as an answer. So next, for since f0.7 into 0.515250 is less than 0, root lies 0.7. So here we go ahead, and that has been 0.515250 here. Now we talk about iteration 2, that has been important one of course. We'll go ahead. Iteration 2 we talk about it. For the same we find it out here. So we'll take as x1 equals to 0.7, x2 equals to 0.515250. So x3 is equals to x2 minus x2 minus x1 upon fx2 minus fx1, fx2 here. We'll put the value here, 0.515250 minus 0.515250 minus 0.7 upon 0.07613 minus 0.644785, 0.00613, which has been equals to 0.517405. So with the same cases we go ahead here, which has been fx3 is equals to f 0.517405 is equals to 0.001070, fx2 f 0.515250 equals to 0.007613, fx1 equals to f 0.7 minus 0.644785, since 0.7 0.517405 less than 0, so root lies 0.7 and 0.517405. Go ahead for iteration 3 here, that is of course being important. For iteration 3 we go ahead, x2 equals to 0.7, x3 is equals to 0.517405, x4 is equals to x3 minus x2 upon f of x3 minus f of, we'll put the value upon which has been 0.001070, which is equals to 0.517708. So here note that second iteration we have here is 0.517405 and third iteration is root 0.517708. So then the root repeats up to 3 digit after decimal, and hence root 0.5177 is the correct up to 3 decimal place. We'll go ahead for the next, and that will be in the results and comment. We talk about it here, and we made a table for the same as well. So with the same, we made a table here. That has been a first important one. So that has been the results and comments. We made a table here, which is that shows the result and the comment of this question. Serial number, name of the method, then we have your value of the root, number of iteration required, comments. For the one and the two here. For bisection, it it is 0.517969. Number of iteration required is 8. And for false position, it is 0.51770A. Number of iteration required is 3. So it is clear that regular falsy method converges the fast compared to the bisection method. In comment we can write it down that as well. So here we go ahead for the next questions that we have to discuss here, which is of course important one, that what we even do have to talk about it. When we are solving those type of questions here, that has been, we have to obtain for it, and that the question will do it. We'll solve the first part of it, and then after that we will be continuing with the next coming class, so that you will get to know about it. So the question we have here: locate the roots of fx equals to x to the power 10 minus 1 between x equals to 0 and 1.3 using bisection method and false position. Comment on which method is preferable. So first we talk about it, and that is being your to obtain root using bisection method. So for that, iteration 1, we find it out. The root lies between 0.0 to 1.3, and hence a equals to 0 and b equals to 1.3. So c equals to a plus b by 2, 0 plus 1.3 by 2, that is b equals to 0.65. F of c equals to f of 0.65 equals to 0.65 power 10 minus 1 is equals to 0.9865372. F of a is equals to f of 0. 0 के power 10 at minus 1 is equals to minus 1. F of b equals to f of 1.3. 1.3 की power 10 minus 1 is equals to 12.785849. Since f 0.65, f 1.3 is less than 0, so root lies between 0.65 1.3 here. For the next we have your, that is being for iteration 2, we'll go ahead for the same. So for iteration 2, it is the new interval we take as a equals to 0.65, b equals to 1.3. So c equals to a plus b by 2, that is being 0.65 plus 1.3 upon 2, 0.975. F of c is equals to f of 0.975 is equals to minus 0.223670. F of a equals to f of 0.65, which is equals to minus 0.986537. F of b equals to f of 1.3, 12.785849. Since 0.975 into f 1.3 less than 0. So root lies in 0.975 comma 1.3. For iteration third, we talk about here. Here we a new interval we take as, that is a equals to 0.975 and b equals to 1.3. c equals to a plus b by 2. 0.975 plus 1.3 by 2 is equals to 1.1375. F of c is equals to f of 1.1375, which is equals to 2.626720. F of a is equals to f of 0.975 is equals to minus 0.223670, and f of b is equals to f of 1.3, which is equals to 12.785849. F of 0.975, f of 1.375 is less than 0. Root lies in 0.975, 1.1375 here. So similarly, the next iteration of bisection method that can be performed to the result of these iteration. So results will draw in the next coming class, because if we go ahead here in the detail about it, so yes, it will be exceeded the time, so we'll not going to do that. We'll start discussing in the next coming class, and for that you have to of course stay tuned with us. You can go ahead with last playlist as well as for this and the coming up next as well. In the same case, we talk about here for the other than CBNST, we talk about it. We had done your sociology and software engineering, and we had done chemistry, which is we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, and as well as unit the conversions, logarithms, anti-log, as well as we had done your, after talking about the anti-log as well, yes, we had done many of the questions related to it, that element with their symbols, with their atomic mass and the molar masses, of course. After talking about that as well, yes, we had done your understanding the human being comprehensively, the human aspiration and its fulfillment, where we had done unit 1, unit 2, unit 3, unit 4, unit 5, with their 2 marks possible question. We are dealing with ER diagrams. We are dealing with English vocabulary, which we can enhance your English here as well. After talking about that, yes, we are dealing with quantitative aptitude. In that we had done your arithmetical ability. We are dealing with, in that we had done operations on numbers, HCF and LCM of number, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems and ages, certain indices, and a percentage we are dealing here as well. After talking about that, we are dealing with reasoning here. In reasoning, we had completed a verbal reasoning, that will be the gender mental ability and the logic reasoning. In non-verbal reasoning, we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis, and discussions. And that has been the important one, of course. Coming towards CBNST, which has been the computer-based numerical and statistical technique, in that we had started with unit 1, which has been the computer arithmetic errors. In that, floating point arithmetic, machine cryptical, round-off errors, chopping error, truncation error, associative and distributive law in the floating point arithmetic, inherent error, error propagation, numerical instability. We had done roots of equation. We had done your second method. We are dealing here. After that, Newton-Raphson methods, then your fixed point iteration method for simple roots and a derivation of their rate of the conversions with the multiple roots, Birch-White method for the polynomial, and Bystrom method for a quadratic equation, fact computer algorithm of these methods as well. After completing that, In Unit 2, we'll have to complete the interpolation and the curve fitting. In interpolation, we have to cover up the algorithm and the error analysis of the Lagrange and the Newton's divided difference interpolation relationship in the various difference operation, piecewise linear interpolation, cubic spline interpolation, National spline, Chebyshev's polynomial approximation, Lagrange equalization of the power series. In curve fitting, we have done a linear and nonlinear least square approximation, third conditioning in the least square method, Gram schematics purposes of orthogonalization, computer algorithm at least square that curve fitting as well. In unit 3, we have to do differentiation and integration. Differentiation, we have to do method based on interpolation and finite differences and Richards extrapolation as well. In integration, we have to do error analysis and trapezoidal and Simpson method, Newton-Gauss integration method, Gaussian integration method, Gauss-Elegante method as well, Lobato integration method and Radon integration method, error terms in the integration method as well. In unit 4, we have to cover up the solution of the simultaneous linear algebraic equation where we have to cover up the Gaussian minimation method, conditional system, condition number, successive over the relaxation method, rate of convergence, solution of ordinary differential equation, we have to cover up the single step method, Runge-Kutta second order, third order, fourth order, multi-step method, predictor and the corrector method as well. In statistical technique, we have to cover the statistical hypothesis, test of hypothesis, type 1 and type 2 error, level of significance test involving the normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and if you can also enjoy the video as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Stay tuned with us and please support us as you had supported till the date. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. And please keep supporting us as you had supported till the date. Thank you.